Welcome to another deep dive. Today we'll be exploring a structure that is so simple, yet so ingenious, the igloo.
Igloos are a great example of humans using simple physics to not just survive, but thrive in one of the most extreme environments on Earth.
It really is fascinating. We often picture igloos as just these, piles of snow, but obviously there's a lot more to it.
Right.
So before we get into the physics of it all, can we just clarify what exactly we mean when we say igloo?
Yeah, good point, because the word igloo can actually refer to many types of Inuit shelters. It's more of a general term for a dwelling.
Oh, interesting.
So like tents or homes made of sod or driftwood, essentially any dwelling.
So it's like an umbrella term.
Exactly. But for this deep dive, we're going to be focusing on the classic dome-shaped snow houses.
Makes sense. Now, I've always been curious about how they actually work, like building a house out of snow when it's below freezing outside. Where does the warmth come from?
Well, that's where the physics comes in. The key is the insulation of compacted snow, specifically wind-blown snow. About 95% of it is actually trapped air.
So it's not really the snow itself that's keeping you warm, it's the air.
Exactly. You can think of it like a natural down jacket. All those tiny air pockets act as barriers, and that slows down the transfer of heat, which keeps your body heat from escaping.
So you stay nice and cozy inside, even if it's freezing outside.
Yeah.
Okay, that makes sense. But why compacted snow specifically?
Well, freshly fallen snow is too powdery and loose, so it doesn't trap air very effectively.
Okay.
But when snow gets compacted by wind or by, people stomping on it, it gets denser. And that creates a much more effective barrier.
So like the very thing that makes the Arctic so cold is also what can help people survive there.
Yeah.
Wow, I never thought about it like that. So we've got the insulation, but what about the igloo's shape? Why the dome? I mean, is that just for looks, or is there like a structural reason for that?
It's definitely not just for looks. The dome shape is a very strong design. It's called a catenary arch. And you see this shape in nature, too, in like natural arches or even a hanging chain.
Oh, yeah, like a natural archway, I see.
It distributes weight really evenly, which keeps the structure from collapsing.
So it can hold up all that snow.
Exactly. That ensures that all those little air pockets stay intact so it can keep insulating.
So it's all connected. The shape helps with the insulation. Fascinating. So the dome helps keep the igloo from collapsing, but how does it actually trap the heat inside? I'm guessing that's where thermodynamics comes in.
You got it. Heat always flows from a warmer area to a cooler area.
Oh, yeah, like how my coffee gets cold way too fast.
Exactly. And the same thing is happening in an igloo. Your body heat warms the air inside, but the snow walls prevent that heat from escaping into the cold air outside.
So the igloo traps the heat.
Right. It's like a self-contained heating system powered by body heat.
Powered by people.
Yeah. But there's another part of this heat flow we have to consider. Convection.
Convection? Isn't that like how heat rises?
That's it. So warm air is less dense, so it rises. So that means the warmest part of the igloo is at the top, and the coldest air sinks to the bottom.
Makes sense.
That's why traditional igloos have a raised sleeping platform.
Oh, so you're sleeping up in the warm air.
Exactly.
That's so clever. Every part of the igloo seems to be strategically designed to maximize warmth and comfort. It's amazing. It's not just about piling up snow. It's about, manipulating the environment.
Right. And there are even more design features that contribute to this, like the entrance tunnel.
Yeah, I was just thinking about that. It seems counterintuitive to have a tunnel leading into a structure you're trying to keep warm.
It might seem that way, but that entrance tunnel is vital for the igloo's temperature. And it even helps with ventilation.
Really?
Yeah.
Okay, I'm all ears.
So the tunnel is usually low and narrow.
Okay.
And that's actually very important. It acts as a cold trap.
A cold trap. How does that work?
So remember how we talked about cold air sinking? Well, same thing here. The cold air from outside flows into the tunnel, but because it's denser, it kind of just stays low to the ground.
Oh, so it doesn't really mix with the warmer air inside.
Right. And because the tunnel slips downwards, it's even more effective at trapping the cold air. It's like a natural airlock.
Oh, that's pretty cool. It's kind of like those revolving doors in fancy buildings.
Yeah.
Trying to keep the cold out.
Exactly. But the tunnel isn't just for trapping cold air. It's also important for ventilation.
Really? I actually wouldn't have thought that ventilation would be a big issue in an igloo.
Oh, it's super important. I mean, for a comfortable living space, you need good ventilation, especially in an igloo. You're using body heat to warm the space, and you're also generating moisture just from breathing and cooking.
Yeah.
So without good ventilation, it could get really stale and damp inside.
Makes sense. So how does the tunnel help with that?
It basically creates like a pressure differential. The warmer air inside is less dense than the cold air outside. So that creates a slight pressure difference.
Yeah.
And that, combined with the, sloping design of the tunnel, encourages airflow.
Oh, okay. So the warm air flows out and the fresh air comes in.
Exactly. It's like
Right.
a natural chimney. So the Inuit people, they really understood how important airflow is. And speaking of comfort, have you ever wondered how warm it actually gets inside an igloo?
Yeah, that's a good question. I mean, obviously it's warmer than outside, but it can't be that warm, can it?
Well, the air near the walls can be close to freezing, but research has shown that the area around where people are can actually get up to 36 degrees Celsius.
Wait, 36 degrees. That's like almost 100 degrees Fahrenheit.
Yeah, even in those crazy Arctic conditions, a well-built igloo can create a really comfortable environment.
That's incredible. It really shows how much thought and planning went into these structures.
Absolutely. And there's one more detail I haven't mentioned yet: ice windows.
Ice windows. Wouldn't that just
Uh-huh.
make it colder inside?
You'd think so, right? But the Inuit people were incredibly resourceful. They knew how to use ice just as well as they knew how to use snow. They'd take a block of clear ice and put it in the wall, usually near the top.
Oh, so it's kind of like a natural skylight? But
Hmm.
how does that help keep the igloo warm?
Well, so light carries energy, right? And when that light hits a surface, it gets absorbed and turned into heat.
So the ice window lets the sunlight in and warms the igloo.
Exactly. It's like a natural form of solar heating. Pretty
Uh,
cool, huh?
That is really cool. They were using solar energy like centuries ago, so they were ahead of their time.
Yeah. It makes you wonder, are there other things we can learn from these traditional building techniques?
Yeah, definitely.
The igloo is a great example of how humans can thrive in really tough environments just by using basic physics.
Well, this deep dive has definitely made me appreciate igloos a lot more.
Me too.
Yeah.
It's a really fascinating blend of practicality and artistry and, a deep understanding of nature. And it shows how humans can adapt and create a sense of home anywhere.
Speaking of home, all this talk about igloos is making me feel kind of cold. I wouldn't mind being all cozy somewhere warm right about now.
Yeah, me too. But before we wrap up, let's leave our listeners with something to think about. We've been talking about all the amazing physics of igloos and how they've let people live in the Arctic for centuries. But could we use these same principles in our modern world?
You mean like take inspiration from igloo design for modern architecture?
Exactly.
Hmm.
Think about it. Igloos are like a masterclass in passive heating and cooling and ventilation. Could we adapt some of those techniques to make our buildings more sustainable and use less energy?
Wow, yeah. It's a really interesting idea. Like, are there things we can learn from these traditional building techniques that could help us today?
For sure. And that's the best thing about deep dives. They make you think about the why, and maybe they even inspire some new ideas.
We've really dug deep into the igloo today, from simple snow hut to a masterpiece of engineering.
Yeah, we've learned that they're actually really sophisticated examples of sustainable design, and a great example of human ingenuity and adaptability.
I know I'll never look at an igloo the same way again.
Me neither. But before we finish up this deep dive, let's leave our listener with one last thought-provoking question.
Okay, so we're wrapping up our deep dive into igloos. We've talked about all this amazing physics stuff. But what's the big takeaway for our listeners? I mean, what can we learn from these structures, even if we're never going to build one ourselves?
Well, I think the biggest lesson here is the importance of, observation and understanding how things work in nature.
Yeah.
The Inuit people didn't have all the fancy science and technology we have today, but they were still able to build these incredible shelters just by paying attention to how heat moves and how materials work and how to work with the environment instead of trying to fight against it.
So basically taking inspiration from nature and using it to solve problems, even in totally different areas.
Yeah, exactly. It's called biomimicry, learning from nature to create new things. And it makes you wonder what else we could learn from nature, what other secrets are out there just waiting to be discovered.
I love that. So could we actually use some of these igloo principles in like modern architecture? But our buildings are obviously way more complex,
Yeah.
but could we still take inspiration from them?
Oh, definitely. I mean, imagine buildings that use passive heating and cooling just like an igloo. We could even have ventilation systems like the entrance tunnel or use new materials that work like compacted snow.
It would be amazing to have buildings that really work with the environment,
Yeah.
using natural resources and not wasting energy.
Exactly. And it's not just about sustainability, it's about resilience too. Like the igloo shows us that humans can adapt and live in really tough places. And as we face, climate change and things like that, those lessons are more important than ever.
It's true.
Hmm,
Sometimes the simplest solutions are the best, especially when they're based on an understanding of nature.
I agree. And there's so much we can learn from indigenous cultures. The igloo is just one example of how ingenious and resourceful people can be.
Well, I think we've done a pretty good job of uncovering the secrets of the igloo. We've gone from thinking of them as just simple snow huts to realizing they're actually really complex and clever designs.
Yeah, and hopefully our deep dive has inspired our listeners to think about the world around them a little differently. Maybe the next time you face a challenge, you'll think about the igloo and ask yourself, what can I learn from nature to help me solve this?
I love that. So, to our listeners, we'll leave you with this. The next time you see an igloo, don't just think of it as a pile of snow. Think of it as a brilliant design, a sign of human ingenuity, and a reminder that even in the toughest places, we can find warmth and comfort and inspiration.
And until next time, keep exploring, keep learning, and keep those brains muzzing.
And remember, there's always another deep dive out there waiting to be discovered.